Hola amigos, today we'll see how to deploy microservices project using Docker. So this is the architecture of this application. In this application we are using 6 microservices. This is e-commerce based application. Here we are using 4 e-commerce based services: offer, source, specialist cart, Joule API, API gateway and UI is built on React. So let's see the working of this application first of all, then we'll get into the details of how to deploy this application. So this is the minimalistic UI of this application. Here we have 4 buttons using which we can display JSON data related to these services. So as I click on the offers related, JSON data will be dumped on the screen. Similarly, cart, list, and source. So the beauty of this microservices is even though one of these microservices is down, the rest of application will keep running without any problem. So let's shut down the specialist container and see how this application is responding, reacting. So moving into the mob external, let's write the command docker stop. After that, the container ID of this list. Select this list container ID, pass, right click, then now see the list will throw error. Probably one of the microservices is down, but the rest of the application is working without any problem. So this is the beauty of microservice based application. Now we will see how to deploy this application using AWS and Docker. As you already know, this is the architecture of this e-commerce based microservices based application. Here we are using 6 microservices. The tech stack uses React.js, Spring Boot, Node.js, Python, and the UI microservice is using React.js running on port 8080. Joule API gateway is running on port 9999 using Spring Boot. Offer services is using Spring running on port 1001. Source microservices is also using Spring running on port 1002. Wishlist microservices is using Python running on port 1003. And the cart microservices is using Node.js running on port 1004. The API gateway, this is created by Netflix Joule API, and the purpose of using this is it manages incoming requests and allows for efficient distribution of traffic and ensures proper load balancing among target endpoints. So this is the UI, as you already know. Now before moving into the deployment process, we should know very basic terminologies related to containerization, virtual machine, monoliths versus microservices. So what are services? Services are typically organized around business capabilities. In case of e-commerce applications, services can be cart, wishlist, UI, offers, API gateway, payment gateway. So each service is often owned by a single team based. A monolith application consists of a single large code base. Terminology you should know is virtual machine versus container. So in virtual machines, physical layer virtualization is happening, whereas in container OS level virtualization is happening. Here in virtual machine, the every virtual machines have their own just operating system, runtime environment, and application code. And the hypervisor is the main intermediary that provides or assists this whole procedure. Whereas in containers, container engine is required for creating containers. Containers only need runtime environment and application code, and they are sharing the same host operating system. For more information about containers versus virtual machine, you can visit this link. So here you will get more info about this versus virtual machine. You can visit this link. So here you will get more info about this. So here we will. So here you will get more information about virtual machine versus container. Virtual machines have their own separate kernels, whereas in containers, same kernel is shared between all the containers. Here OS level virtualization is happening in container, whereas hardware level virtualization is happening in virtual machines. The next terminology you should know is image versus container. Image is a blueprint template for application that is static and read only, like the ISO image of Windows operating system, and container is running instance of an image, dynamic and mutable. More bits you can read all this, and here you can read even more details. So without getting into the details of image versus container, Docker Hub is the default global marketplace for storing and distributing images. So you can store your customized images on Docker Hub. So how to Dockerize or containerize an application. So what is Docker first of all? Docker is a platform as a service product that uses OS level virtualization. That means containerization concept. So what is the process? First we have to create a Docker file. Then using Docker build command we will create a Docker image, and using the Docker run command we will create a Docker container. So what is a Docker file? Docker can build images automatically by reading the instruction from a Docker file. So in Docker file we provide instruction to the Docker platform to create Docker image in a declarative way so that it can assemble an image. This is an example of Docker file. So the from keyword specifies the base image, the runtime environment. Here is no 16th version. The second command is work directory slash app. Means set the working directory inside the container to slash app and copies files from the host to the container. Third command copy package.json to the current directory of the container. Fourth command is run npm install. It executes the commands to set up the container. Fifth command copy current directory to current directory. Period operator to period operator. Rest of the application code to the container from host. Expose 3000. This is useful just documentation purpose. The last command cmd npm start is used to run the application. So for Dockerizing this, so for Dockerizing, this application, we need to create Docker file in each of these services. So this is the repo which I am using, all from Vikas Kumar, also known as Mr. DevOps on YouTube. So within each services, we have to create a Docker file. The names would be in this format, and inside the Docker file, we need to pass commands such as what is the runtime environment we are using, the directory name, and we have to copy the source code from the host to the container, then install all the dependencies, then expose, install what port this service will run, and then execute this container. Generally, we will do this for all the services. Cart offers source UI acceleration tool API gateway. So Docker for image versus Docker container. A Docker image is a lightweight standalone and executable software package that includes everything to run a piece of software, including the code, runtime, environment libraries, environment variable, configuration files. How to create Docker image? The command is docker build -t for tag, then the image name. After that, the period operator for current directory. It builds an image from the Docker file in the current directory and tags it as whatever name you provide. The Docker container. Docker container is a runnable instance of a Docker image. It encapsulates an application and its dependencies but provides the added isolation via containerization. So how to create Docker image? Docker run -det for data for port, and after that the host port number map to the container port number. After that the image name we have created using the build command. So what is the need of this port mapping? Port mapping bridges your host machine and the container, making the app accessible outside the container. Okay, so if you are running a web application, for example, Node.js inside the container, and it's configured to listen on port 3000, you can access it in no browser. So the steps to Dockerize the microservices project is as follows. First, we have to create a EC2 instance inside AWS, and the server types will be G2 medium, and the inbound routes will be all traffic. So first of all, let's move into the AWS console. within AWS console, select EC2 service, start launch instance, give it name Microservices, select an image Ubuntu, select the instance type is T2 medium, T2 medium selected, select a key pair or create a new one if you don't have. I'm selecting my already created key pair. Now edit this network setting, go to inbound rules, type to all traffic, and increase the storage to 10 GB. All our selections are listed here. Number of instance 1, AMI type 122 T4.04, T2 medium, firewall, and storage volume. Now launch. Our EC2 instance is launched. Meanwhile, we will see what we have to do is to SSH into the EC2 instance. So for SSH into EC2, we will use Movaxter. So first of all, see the status of the instance. It's successfully launched, created. Now click on this instance ID, copy this public IPv4, move to Movaxter, click start new session, SSH, paste public IP, to instance advanced SSH setting, select private key, select the location of the key. This is my key pair and OK. Accept. The next step is sudo as a super user, login, pass Ubuntu. Now clear the screen. Sudo super user. Now cd move into the root directory, and the first step we should do is to update apt-get update the server update. The next step is to before cloning the GitHub repo, we will paste the public IP into the UI app.jsx Joule API application.ui.yaml. Okay, now moving on to the AWS console, copy the public IP. Now moving on to the repo. So this is the Microservices based Docker repo which I got from the customer, also known as Mr. DevOps. A big shout out to Mr. DevOps. You can or you may follow him if you like. So search for app.jsx. Yes, within that, now edit this file, and here we need to paste the public IP. Now commit changes. We can do this thing in the ACT server, but for beginner friendly, to keep it beginner friendly, I am doing it within the repo only. Application, and this file should be inside Joule API gateway. So here 4 times we have to paste this. Do it properly. So what is this? This is Joule API gateway. Application triangle file. What is the significance of this file? So here. So what is the significance of this file? Application.yml within Joule API gateway. So copy paste this command. This all source code within ChatGPT, and the whole breakdown of this configuration file is presented here. This is the YML file server. The Joule API gateway is running on port 9999. All incoming requests will be handled by Joule API on this port. Joule API routes. Joule will forward requests based on these routes. Offers microservices, path will be /offer, and URL will be public IP port /API /v1, only for all the microservices. So now moving on to the deployment process. Next thing we need is to git clone this repository. Now move to the root directory, copy the path. Now move on to Nova Extreme, ls, so git clone space, right click, now ls, it is our Microservices Docker file cd, now select this thing, right click, enter, ls. So our Microservices Docker folder, all the contents are visible. Now the next step we need to do is to cd into microservices. We already did that. Now we need to install Docker. So Docker related all the commands are stored within this cell file or bash file. Now let's see the details of this file cat space docker.sh. Now first of all we need to provide the executable permission to this file, and after that we need to do is to docker period slash docker.sh. Let's see the next step. What we need to do is to this step 8 is already completed. Now cd into which service folder and build image using docker build -t image name, then period operator for current directory. That's 90%. Alright, so Docker installation is successfully done. Let's see the Docker version. Docker version here 24.0.2. Now let's all directory, cd into, let's start with the UI. Docker build -t tag name UI and current directory. Now the Docker build process started for UI, which is using React.js. Here loaded the getting now file. Here the Docker file is loaded. Size of Docker file is 121 bytes, and this is happening in stages, in layers. Almost this process is about to complete. So let's check whether this image is successfully created. Yes, this image is successfully created. Now let's move to root directory, list cd. Now let's move into the Joule API and press the up arrow and just change the name to API. So this is using Spring. Stage 1 by 1 by 3 is executing here. OpenJDK is installing for Spring. Maven is installing the dependencies. Build process 4 is successfully executing. Let's move to root directory again. Let's check whether this is created successfully. Yes, this one is created. Now let's install directory cd to cart. Within cart directory, we will create the docker build -t cart space current directory, and the cart is using Node.js runtime environment. The file, the size of Docker image for UI is 1 GB, and the for the Joule API is around 339 MB. The size of Joule API is small because here we are using multi-state Docker file. I will explain the multi-state Docker file in next session. Let's cd into root directory, ls, Docker images. This size of cart is around 1 GB again. Then let's cd into offers, and offers, rename it offers, execute, and see here our directly step 4 by 4. Here 4 by 4 is executing because already this Joule API is using Spring. That's why the cached stage 1, 2, 3 is cached here. That's why this build process executed very fastly. Now cd into root directory and docker images. Their offers is created successfully. Now ls cd into source. Rename it source. Now here this is also using Spring, that's why this build 5.4 is running using Maven. Now cd docker images. Ls cd into the last vessels directory. Within this name it, we will name this directory list. This is using Python. This will take some time. And we have to create build thing. We have to first go inside that directory, then only we have to create the build. But for containerizing, there is no such restriction. You can pass the docker run command anywhere. So let's see, the next thing we have to do is to create Docker container using docker run -dd for data storage, p for port. Here port mapping is happening. Then the image we have created here is passed here. Image name should be same. Now cd to root directory ls. Now docker images. Everything is in front of us. Docker run -d-p. And now moving on to the architecture piece. Here the port name should be same. For UI we are using 8080. Mapping to 8080. The name of the build images, docker images UI. Let's execute this. Not found. Docker this here is spelling typo mistake. And yes, that's a. Let's see. Container is successfully created. Now let's again running for Joule API. Running on port 9999. Mapping to 9999. Joule API. You continue. Joule API. Not this thing's happening. Docker run -p 9999 running on port Joule API. Let's check it out. 9999 Joule API. Here typo mistake API. We can see the application up and running here. Copy the public IP and port 8080. Meanwhile, as the application is loading, meanwhile we will create the next container. So let's see the architecture running offers running port 1001. See the spelling, no more typos. Let's see whether this application is running on. Yes, the application is up and running. And offers, let's list all the containers. On the container offers is running means offers should display the offer related JSON data on the screen. Let's see. Yes, this offer is running, but the other microservices are not running as they are still waiting for their containerization process. So let's do it for others. (1002). The application is source services running on 1002. This whole manual process can be automated using Docker Compose that I will show you in the next session. Now let's containerize the next services. With list. See the spelling with list is the this list. Yeah, correct running. The next one is cart. Cart running on port 1004. Let's do this. Change this port to 1004. So docker ps -a. All services are up and running. Cart facility source offers all six microservices are up and running. That means this application should work. All the microservices on this application must display JSON data on the screen. Sys is working, cart is working, office is working, and source is working. So that's all for this demo session. So in the next session, I will show you how to automate this whole manual process of creating build and containers using just one file, Docker Compose. So thanks for watching everyone. If you have any query or request, just let me know in the comment. Thanks for watching.